So today we have nice algebraic system of equations. The first equation is x square plus 4y square plus 9z square equals to 189. The second equation is x minus 2y plus 3z equals to 9. And the third equation is 3xz equals to 4y square. Now the question is to find the values of x, y and z in the real plane which satisfy these three equations. So this is Anmol Mishra, and now let us see the solution. How can we find the values of x, y and z? So first of all, let us label these three equations. So let this be equation number 1, this one be equation number 2 and this one be equation number 3. Okay. Now in the third equation we can see that 3 times x times z equals to 4y square. So we can simply replace the 4y square in the first equation with this particular value. So now we will have x square plus 3 times xz plus 9z square as equals to 189. Now carefully look at this particular equation. I will simply add and subtract 3 times x times z, that is the middle term over here. So we will have x square plus 3 times x times z plus 9z square plus 3xz and minus 3xz, and this thing is equals to 189. Now over here 3 times x times z plus 3 times x times z will form 6xz, and in the beginning x square plus 6xz plus 9z square minus 3xz, and this thing is equals to 189. Now carefully see that the first term is x the complete square. This particular term is 3 times z the complete square, and in the middle we can write 2 times x times 3 times z, and this thing would be same as 6xz minus 3xz equals to 189. Now here we have the nice identity a square plus 2ab plus b square. So it can be written as x plus 3z the complete square minus 3xz equals to 189. So over here we have got a very important equation, and by taking the help of the second equation we can even solve this particular one. So here we have the second equation, and it says x minus 2y plus 3z equals to 9. We can simply add 2y on both of the side. So the left hand side will turn out to be x plus 3z, and this thing would be equals to 9 plus 2y. Keep this equation as it is, and from the third equation we already have that 3 times xz equals to 4y square. Now look at this equation that we got previously. Inside the bracket we have x plus 3z, and x plus 3z has a value that is equals to 9 plus 2y. So we can simply replace the bracket as 9 plus 2y the complete square minus 3xz. So from this third equation we have that 3xz equals to 4y square. So we can simply replace the 3xz as equals to 4y square, and this thing would be equals to 189. Now you can see that we have got an equation in which the only variable present is y. So we can simply solve this. So if I open the bracket, we will have 81 plus 4y square plus 224 into 9 36 times y minus 4y square as equals to 189. 4y square got cancelled out. So what we finally get is 36 times y equals to 189 minus 81, that's 108. So the value of y we get is equals to 3, because from the table of 36 it goes 3. So here we've got the value of one of our variable, that is y equals to 3. Now let us find out the values of x and z using this. So here is the complete working how we got the value of y. So now what we need is the value of x and z. So what we will do is we'll simply replace the value of y as equals to 3 in this particular equation and in this particular equation. So let us see what happens next. So now let us replace y as equals to 3 in this particular equation. So for y equals to 3, the left hand side will remain as it is because no y is present over there, and the right hand side will turn out to be 9 plus 2 times 3, that is 9 plus 6, and it would be equals to 15. So x plus 3z equals to 15 becomes a nice equation. Now take this particular equation in which we have 3 times x times z equals to 4y square. So for y is equals to 3, the particular equation will turn out to be 3xz equals to 4 times 3 square, that is 36. And if we will further simplify this, we will have x times z equals to 12. So here we have got the second nice equation. Now let us find the values of x and z using these equations. So from this equation we can simply say that the value of z is equals to 12 upon x. So here we have got the value of z in terms of x. So in this equation we will replace this z with this particular value. Therefore x plus 3 times 12 upon x is equals to 15. So we will get x square plus 3 into 12 36 equals to 15 times x, and if we will just simplify this thing, we will have x square minus 15 times x plus 36 is equals to 0. So here we have got a quadratic equation. So let us simplify this thing. So over here the coefficient of x square is equals to 1. So we can simply use the factorization method. So 36 can be written as 2 multiplied by 18. This can be further factorized and can be written as 2 into 2 into 9, and this can be written as 2 into 2 into 3 into 3. So this is the final factorization of 36. So let us form the number 15 using this. So we have 2 into 2 into 3 into 3. So we can simply say that 2 to 4 into 3 12 plus 3 is equals to 15. So here what we can do is like this way: x square minus 12 times x minus 3 times x plus 36 is equals to 0. We have simply split at negative 15x as negative 12x and negative 3x. So here x taken common, so x minus 12. Here we can take negative 3 common, so x minus 12, and this thing is equals to 0. So x minus 12 multiplied with x minus 3 is equals to 0. So either this is equals to 0 or either this is equals to 0. So if x minus 12 is equated to 0, we get x is equals to 12. And if x minus 3 is equated to 0, we get x is equals to 3. So here we have got the value of x is equals to 12 and 3. Now let us put this value of x in this particular equation so as to get the value of z. So we'll change the color. So the value of z is equals to 12 upon x. So z is equals to 12 upon x. For x is equals to 12, the value of z would be equals to 1. And for x is equals to 3, the value of z would be equals to 4. And in both the cases, the value of y was equals to 3. So now let us write down the final answer which satisfies this three equation. So the values for x, y and z which satisfy this three equation is 12, 3, 1, and the second pair is 3, 3, 4, and that's the answer that we were looking for. So this was my way to solve this particular question. If you have any other method other than this, you can do comment below, and if it's hard to comment, you can email me or else you can send it to me on my Instagram. The link is in the description.